Welcome to this comprehensive tutorial on object-oriented programming in Python. Object-oriented programming is mainly built on four core principles, namely encapsulation, abstraction, inheritance, and polymorphism. Let's see how encapsulation works. Just think of a juice box. Inside it, you've got the juice, that is data in our case. And also, you have a straw, that is the method here, to access or modify that juice. But you can't just stick your hand into, grab the juice. Definitely you have to use the straw. Because the box keeps everything bundled neatly, and controls how you use it. That's what a class does in code, it wraps up variables and functions together and hides the messy things inside. Next comes abstraction. Imagine you're driving a car. When driving, you don't need to necessarily know how the engine works, how the fuel burns, or how the brakes are built. What you really need to know is to control the car by using the steering wheel correctly, and also by controlling the pedals accordingly. That's abstraction, only showing you what you need to use, and hiding the complex stuff behind the scenes. Let's see what inheritance is. Imagine you have a vehicle class, kind of like a parent. Now you want to make a car and a bike from this vehicle class. The car and the bike can inherit common things like speed or fuel capacity from vehicle, instead of writing everything from scratch. It's like how kids inherit traits from their parents, eyes, hair, and voice, etc. Lastly, we come to polymorphism. Here you get same action, but different results depending on who is doing it. Say you've got a method called makeSound. A dog might bark, a cat might meow, and a bird might chirp. But you call the same method, that is makeSound. Each one responds differently. That's polymorphism, same name, but behavior changes based on the context. Alright. Let's dive into the code. Chapter 1, Getting Started with Classes and Objects. In Python, everything is an object. An object is a collection of data variables and methods functions that operate on the data. The blueprint for creating objects is called a class. Let's start by creating a simple class and understanding how to instantiate objects from it. Let's define a simple class. Class car. So let's start typing def, this is for define, init, and then self. Then again type make and model. Then you type self.make equals and type the word make again. Next you type self.model and then equals model. Now instantiate objects of the class. Let's begin with car1 equals car, then the brand, Toyota, and the model, Camry. Next, type car2 equals car. After that, the brand, Honda, and the model, Civic. Finally, access object attributes. Let's type print car1.make and car1.model. Again in the next line, let's type print car2.make and car2.model. We define a class car with an init method, which is a special method called a constructor. It initializes the object's attributes make and model when an object is created. We create two instances of the car class, car1 and car2. We access the attributes of each object using dot notation, like object.attribute. The output is Toyota Camry and Honda Civic. Chapter 2, Class Methods and Attributes. In addition to attributes, classes can have methods that define behaviors. Let's add methods to our car class to demonstrate this. Let's type def, display info, and self. Now, type print. And within an F string, type make self.make and model self.model. Now instantiate the object and call its method. Then type car equals car Tesla Model S. After that, let's print car.displayInfo. We define a new method, displayInfo, within the car class to display the make and model of the car. We instantiate a car object named car and call its displayInfo method. The output is make Tesla Model S. Chapter 3: Inheritance. Inheritance is a powerful feature of object-oriented programming that allows classes to inherit attributes and methods from other classes. Let's create a subclass electric car that inherits from the car class. Let's type class electric car and car. Next, we type def init self make model and also the range. In the next line, type super.init make and model. And let's type self.range equals and again range. Next, type def display info. And also type self. Then type super.displayInfo. Next, type print f string range self.range miles. Let's instantiate an object of the electric car class. Let's type electric car equals electric car. The brand Tesla. The Model 3. And finally the range, 310. And also, type electric car.displayInfo. We define a subclass electric car that inherits from the car class using parentheses after the class name. We override the init method to add a new attribute, range, and the displayInfo method to include the range of the electric car. We instantiate an object of the electric car class and call its displayInfo method. The output is make Tesla Model 3 and range 310 miles. Chapter 4: Encapsulation. Encapsulation is the bundling of data attributes and methods that operate on the data within a single unit class. In Python, we can control access to attributes using property methods. Let's type class person. Next, type def init self and name. And also type self.name equals name. Now type def getName, and self. Next line, type return self.name. Let's type def setName self and name. And self.name equals name. Instantiate an object and access private attribute using getter and setter. Let's type person equals person Alice. Next type print person dot getName. And also type person dot setName Bob. Finally, type print person dot getName. We define a class person with a private attribute name using double underscores. We provide getter and setter methods getName and setName to access and modify the private attribute, respectively. We instantiate an object of the person class and demonstrate the use of getter and setter methods. Output is Alice and Bob. Chapter 5, Polymorphism. Polymorphism allows objects of different classes to be treated as objects of a common superclass. This is achieved through method overriding. Let's type class animal. Next, type def, speak, and self. After that, type pass. Then, type class, dog, and animal. After type def, speak, self. And then, type return woof. Next, type class, cat, and animal. And type def, speak, self. Finally, type return meow. Instantiate objects and demonstrate polymorphism. Start typing dog equals dog. And cat equals cat. Next, type print dog.speak. And finally, print cat.speak. We define a superclass animal with a method speak. We define subclasses dog and cat that override the speak method. We instantiate objects of the dog and cat classes and demonstrate polymorphism by calling the speak method on each object. Output is woof and meow. Congratulations! You've learned the basics of object-oriented programming in Python. This tutorial covered classes, objects, inheritance, encapsulation, and polymorphism. Practice these concepts by creating your own classes and exploring more advanced topics in Python object-oriented programming. Happy coding!